Hello everyone, welcome to today's chapter 7 multi-variable calculus section 1 functions of several variables. This is Izaldi's Williams and Yuri economics. Let's jump right into it. The learning of the objective of section 7.1, the functions of different variables. Here you will be able to identify functions of 2 or more independent variables, mostly 3. The students will be able to evaluate functions of several variables. You will also be able to use three-dimensional coordinate system that can be explained by like this, shall we say, with more variables than we can have. Functions of 2 or more independent variables. As an equation of the form z equals the function xy describes a function of 2 independent variables. If for each permissible order pair xy there is one and only one z determined. The variable x and y are independent variables and z is the dependent. An equation of form w equals f x y z, that's the function of 3 variables, described as a function of 3 dependent variables. If for each permissible order triple 3, there is one and only one w determined. For a function of 2 variables, that's for domain and range, z equals the function xy. The set of all orders pay the permissible value of x and y is the domain of the function, and set of all corresponding values, function is y is also the range of the function, unless, and be careful with this one, unless otherwise stated in the equation itself. We will assume that the domain of a function specified by an equation of the form z equals the function xy is the set of all orders pairs of real numbers, function x, y, such that function x, y is also a real number. It should be noted, however, that certain conditions in practical problems often lead to further restrictions of the domain function. Examples: the cost function of a company or whatever, cxy equals 1000 plus 50x plus 100y. Find f5 and f10. Usually, the f10 as we know it is mostly the y, and the x as we know it is mostly the x. So you can go for the second part. For this is the solution. For x, y, the z, the f and 10, the 1000 as it's always written here, the 50 and the 5 is the x, and the 10 is the y. Here is as shown about it, that's the final reason. For 3 variable function, x2 plus 3xy plus 3xz plus 3xy plus z2, the 2 and 3 and 4, the 2 and the 3 and the 4, which is shown here, the x and the y and the z. Here it goes back, we shall see the 2 as is the 2 plus 2, the 2 powered by 2, 3 multiplied, this is the x and this is the y, the x as x here and the y, the 3 and then y here, plus 3 multiplied by x and z, x as the 2 as we used before, the 4 as it's shown here, and it goes on and on as the same pattern, and then it's 98. You can calculate it yourselves. Then continue it. There is a number of concepts that we are familiar with that can be considered as a functions of 2 or more variables. These things actually can be used in real life applications, in engineering mostly, but at manufacturing most of the things. For example, like carpets, like tiles, that actually requires area of measurements. These concepts actually help us do that. Area of rectangle, for example, I and W, this is actually I and W. Volume of rectangular box, that is WH, when you are using something like this, and it's actually also can be used in 3D dimensions. Example as then continue it. Economists use Cope-Douglas production function to describe the number of units fxy produced from the utilization of x units of labor and y units of capital. This function is the form of function xy km kx m y n, where k and m and n are positive constant with m plus n equals 1. Cope-Douglas production function. The production of an electronic firm is given approximately by the function fxy 5x powered by 0.3 multiplied by y powered by 0.7, with the utilization of x units of labor and y units of capital of the company is 5,000 units and labor and 2,000 units of capital. How many units of electronics will be produced? Be careful here that they identified the x and identified the y without you even focusing about it. It's already actually identified. These kind of questions are tricky, but if you focus, it will be a piece of cake. The functions as we written, of 5,000 and 2,000. This is the X here, and the other girl is the Y. Pretty easy, pretty simple. The three-dimensional coordinates. We use these kind of things in the system is formed by three mutually perpendicular number lines and intersecting as their origins. In such system, every order triplet numbers x, y, and z can be associated with a unique point, and conversely, we use a plane such as the one to the right. A plane such as the one to the right to display this system on a plane. Actually, we use these kind of things mostly in like the plane, but mostly common uses in a 3D coordinates. Locate 3, -1, and 2. These are the dimensions that's actually required from us. You can see it again, 3, which 3 is the x, the -1, and the 2. That was pretty easy actually for us. The graph, considering the graph of z equals x2 plus y2. If we let the x equals to 0, that means z will be equal to y2, because 0 powered by whatever still equals 0. And whatever number, whatever 0 powered by whatever number is still going to equal 0. So at the end is going to be y2, which we know as the standard parabola in the yz plane. If we let y equals to 0, the equation becomes z equals x powered by 2, which we know as the standard parabola in the xz plane. The graph of this function, z equals x2 plus y2, is a parabola rotated about the z-axis. This surface is called parabola. And these kind of things actually used in real life in automobile headlights, reflectors, and the other paths to determine the path of like a ballistic missile long range. Graphing the surfaces. The sum graph is calculated as the ability to graph the three variable function. This is like the face of the calculator, and this how much they can do it. However, many graphing calculators only have the ability to graph two variable functions. With these calculators, we can graph cross sections by planes parallel to the xz or the yz plane to gain insight into the graphs of three variable functions. Here is the cross section of z equals x2 and y2 as of the graph of zx 2 plus 0. And here's the same point if you are talking y equals 2, so the graph is zx2 plus 4, as you can see here. Graphing the surface, same thing as you can see here. At the summary of this place, you have, after you study this and after you focus on this, you will be able to define a two or more independent variables. The second you just saw them. We saw actually here several functions, that is including the Cobb-Douglas production functions, which for economists is pretty important because it determines a lot of factors and can actually make the calculations when it comes to production and cost and revenue pretty easy. I will also define it and use the three-dimensional coordinate system. Thank you very much. This has been Easy Swalem. Have a nice day.